All right, good morning. Welcome. It's Tuesday, and today we are talking growth and decay. I didn't get any remind questions last night about the homework, so I'm assuming that you got the answers that were provided to you on A78. Again, if you have questions, please text me through Remind, and I can answer those questions. Today, you're going to need a calculator, so take a minute and grab that. And you also probably need to put on your little seat belts of math. Today is the application of growth and decay. So what we've been doing the last 2 days, now we're going to turn into actual problems. All right, let me give you just a second to get your notes together. We're starting on growth and decay, 79. And you'll notice at the top, every solution to the equation dp dt equal kp can be written in this form. And we explored that yesterday when we had e to the power and then you realize base log base. P of 0 is your initial value, and if k is greater than 0, it's going to be growth, and if it's less than 0, it's going to be decay. All right, let's just get straight to it. By the way, I'm sure you're going to have this question, not this particular question, but you're going to have a series of questions like this on the test, on the exam. Coffee's going to get hot or cold. Pizza's going to warm up or cool down. Glue, glass, whatever. Things are going to get hot or they're going to get cold. Money's going to grow or it's going to go away. So let's get comfortable with these problems so that we can get as many points as possible off of this. So here we go. A cup of coffee, temperature 180 degrees, is placed on the table in a room at 68 degrees. So here we go, right away. We know it's going to be a growth or decay. And more than likely, we're going to be cooling the coffee off. That just would make sense. The differential equation for its temperature at time t, dy dt, negative 0.11 y minus 68. All right. Then they also go on to tell us at time 0, it's 180 degrees. And that just reinforces what they said here about the initial temperature. And they want to know 3 things. After 10 minutes, what's the temperature of the coffee? How long does it take the coffee to drop to 75 degrees? And what is the average temperature? Now, they said they may not be asking us averages, but I would be prepared for it just in case. We're going to go ahead and go through with that. All right, here's how we start. We have a differential equation. We have dy dt negative 0.11 y minus 68. So everything that we've been doing the last few days, we're just going to continue doing. We're going to separate. I want the y's on the left and everything else on the right. Remember, you cannot separate with addition or subtraction. So this entire piece, y minus 68, we're going to divide by that. So I have dy over y minus 68 is negative 0.11 dt. There's our separation point. Now, we're going to integrate, right? So 1 over the stuff, the antiderivative is going to give me ln y minus 68, negative 0.11 t. There's the variable. If you accidentally write x, that's not a big deal, plus my constant of integration. We've separated. We've integrated, we've added our constant of integration, and now we're going to use our initial condition to find out what the variable c represents. And they told us right here, at time 0, we're 180. So again, here's my x value or my t value, here's my y value. So let's plug that in. So we have ln 180 minus 68. Negative 0.11 times 0 plus c. You can drop the absolute value bars because 180 minus 68 is going to be positive. So you have ln 112 is c. All right. I'm sorry. Separate, integrate, constant of integration, and now we've evaluated that constant of integration using the initial condition. So again, on a 9-point question, you are already 4 points into this, and it's really not that difficult. All right, let's go find the harder points together. So we now have ln y minus 68 is negative 0.11 t plus ln 112. Now you've got your circular reasoning here. So now we're going to say, wait a minute, e to all of this, remember this unwritten e here, well that's a bad e to all of this is that. So when we do that, and some of you may already see what's about to happen, but we've got e to the negative 0.11 t plus ln 112 equals y minus 68. Now, let me jump up here real quick. Everybody good there? All right. Let's see if I can keep it both on screen. So remember, we talked about this yesterday and the day before. We have e to the negative 0.11 t times e to the ln 112. Well, e to the ln 112 is 112, base log base. So that's going to be, we talked about CERT yesterday. Today it's going to be PERT. So here we go. We have 112 e to the negative 0.11 t equals y minus 68. And then final equation, y is equal to 112 e to the negative 0.11 t plus 68. So there's your equation. All right, now, after all that work, you still haven't answered the question. You've just gotten in place to answer the question. But you have to do all this to get there. So here we go. After 10 minutes, what's the temperature of the coffee? Well, all right. Now that I have my equation, we're saying when T is 10, what's the temperature? Well, easy. We just plug it in. Y equal 112 e to the negative 0.11 times 10 plus 68. Just use your calculator. Let's see if that shows up. Yeah. So I've got e to the negative 0.11 times 10. Let me evaluate that. We're going to multiply that by 112, and we're going to add 68 to that. And the temperature of the coffee is 105.281 degrees at 10 minutes. So actually answering the question is very easy once you get the equation set up. Everybody agree?
There's only 5 to 6 seconds delay. So
Okay. Okay, thanks.
No questions yet.
Okay. Okay, let's move on to B then. Approximately how long does it take the temperature of the coffee to drop to 75 degrees? Well, now they're giving you the Y value and they want you to find the time. So again, we're going to go back to our equation, Y equal 112 e to the negative 0.11 t plus 68. Now we're looking for the t, the variable t. Let me highlight that because this blue is getting kind of... And they've given us the Y value, the temperature. So 75 equal 1112 e to the negative 0.11 t plus 68. I am running out of paper. Hang on one second. Let me get a piece of paper real quick. All right, sorry about that. All right, we're going to move the 68 to the other side, of course. And we got 7. We're going to divide by 7 divided by 112. Type in 13, not 12. So now we have 0.0625 is e to the negative 0.11 t. All right. Now we need to pull that. Let me leave that up here, but put this off to the side. Okay. Now we need to get this variable out of the exponent. Remember, we're going to take the log of both sides. So ln 0.0625 is ln e to the negative 0.11t. Doing that allows you to move this exponent to the front, laws of logs. So ln 0.0625, negative 0.11t, ln e. Of course, ln e is 1. So there that goes. So now I've got ln 0.0625 divided by negative 0.11 is the time that it takes the coffee to get to 75 degrees. Usually when I'm evaluating this, I do it in 2 separate steps. I'm going to evaluate the natural log first, and then I'm going to divide that by the given. All right. There's our answer. Well, I'm sorry, that's a little dark and hard to see. See if that's better. There we go. So it takes the coffee approximately 25.205 minutes to get to 75 degrees. So see, again, once you get through all of this, answering the questions really isn't that bad. And that's why so many points come from all of this. And because it's so important. All right, now on part C, find the average temperature. Remember, average temperature is your integration, and it's 1 over b minus a times your integral from a to b. Again, I'm not sure if they're going to test us on this, but I would sure be prepared for it because it's such a basic question. What's the average number of ticket sales? What's the average number of people in line? What's the average number of cars waiting at the stoplight? All these questions come up time and time again. So we're going to go ahead and prepare for this. And they're asking us the average temperature during the first 10 minutes. So what I'm going to do is 1 over 10 minus 0. We're integrating from 0 to 10. And the question is, what are we integrating? Well, we're integrating the equation that we came up with. 112 e to the negative 0.11t plus 68. And no, you won't have to do that by hand. That would be horrible. So here we go. We're going to go to, let me clear this out, make sure we can see. All right. This is going to be a calculator skill, and what you're going to need to do, go to Y1. Let's type in our equation. So I've got 112 e to the negative 0.11x plus 68. Okay. I'm going to go back to my home screen, second mode. And now math 9. We're integrating from 0 to 10. And this is where we're going to capture from the y that we entered in. So we're going to hit vars, y vars, enter. It defaults to y1. That's the one we need. That's where we typed in our equation. So there we go. We're going to integrate the equation that we typed in y1. And of course, in your calculator, it's all respect to x. Okay. So you have this number. Biggest mistake we make when we're finding averages is forgetting to multiply that by 1 over whatever. So basically, we're just dividing by 10. And the average temperature of the coffee in 10 minutes is 135.925 degrees. So again, you get back to what if this is an actual free response question? Well, here we go. Let's look at, here's probably how the points would be distributed. Separate, integrate, constant of integration using the initial condition, and coming up with the equation. There would be 4. 5 is probably your answer to the coffee at 10 minutes. 6 would be how many minutes it takes it to average. 7 is going to be adding the 1 over b minus a. 8's going to be writing the integral. and 9 is going to come from your answer. So you have to keep in mind, on free response questions like this, usually the average is 2 to 3 points total. So if you can knock out these first 4, you're doing really well. And if you can knock out the first 4, chances are very high you're going to come up with the rest, because the questions really aren't that difficult after you get through the step 1. All right, let's go to the back. Hang on, I've got the wrong paper. Okay, another very common thing, bacteria growing, or I guess viruses, in today's world. Okay, at any time greater than 0 or equal to, that's important, to 0 in days, the rate of growth of the bacteria population is given by y derivative ky, where k is a constant, and y is the bacteria present. So again, remember, y derivative is dy dt. So they're giving you your differential equation right there. The initial population is 1,000, so at time 0 we have 1,000, and you just want to set that aside for future. And the population triples in the first 5 days, so at time 5 I've got a population of 3,000. So write an expression for y at any time of t greater than or equal to 0. So again, here we go. Here's my differential equation. dy dt is ky. We're going to separate. Step 1. We're going to integrate. Antiderivative of 1 over the stuff is ln1, ln the stuff, and then you have k times t plus c. Now, the initial condition is that at time 0 we have 1,000 bacteria. So I have ln 1,000 is k times 0 plus c. Therefore, c is equal to ln 1,000, which means that's going to be the number in front of your CERT or PERT, whichever way you prefer. So when I plug this back in, I have ln y is k times t plus ln 1,000. Let me separate this. Which means e to the kt plus y plus, e to the k times t plus ln 1,000. Again, base log base. Y is going to equal 1,000 e to the kt power. All right, there's a new twist though now that's going to be a little bit different. And basically, you've done base log base. Well, you're going to do it again. And let me just show you how this is going to happen. So here's our expression for the time t, except my problem is we've got these 2 variables here, plus the variable y. So that's going to be impossible to solve until you know some of this. So we're going to talk about this briefly. They tell me that at time 5, I have a population of 3,000. All right, well, let's just use that information. So my population is 3,000 at time 5. So now we have 3,000 is 1,000 e to the 5k. All right, well, let's solve for k. We're going to divide by 1,000. So 3 is e to the 5k. All right, we're solving for k. We're going to take the natural log of both sides. So ln 3 is 5k ln e. Remember, I can bring my exponent to the front. Ln e goes to 1. Excuse me. Excuse me. So ln 3 divided by 5 is the k value. Okay, well, hang on. Let's go back to our original equation. So y equal 1,000 E. Now, in this case, I'm telling you the K value is equal to ln 3 divided by 5. So ln 3 over 5 times T. If you look at it closely, you can see you have base log base. So what I'm getting at, just up here in this exponent, we have a constant T over 5 times ln 3, and it's e to that power. I can separate it like this, right? Well, if I do that, I have e to the T over 5 times e to the ln 3. E to the ln 3, base log base, is 3, and we're going to change the e value to 3 because it is. So now I've got 1,000 times, well, e ln 3 is 3, so 3 to the T over 5 power. So what you've done, this is, hang on just a second. What you've done, you settled here and you said, okay, in the case of y equals c e to the RT, we found the c value of 1,000 base log base. Great. But the pattern repeats itself because now you have e to the kt power. Well, if you solve through for the variable k, given that condition, you find that you've got a new base of 3. So work that through a couple of times because that's going to take some getting used to. But it's nothing you haven't done before. You're just doing it once and then you're doing it twice. Okay, so when I come, I'm going to bring this all up to the top. So now I know the expression for y is 1,000 times 3 to the T over 5 power. And there's A. Now, let's move on. It's kind of messy here, but that's all right. Let's move on to B. By what factor will the population have increased in the first 10 days? So what are they giving me? Well, they're asking me what y will be after a time period of 10. So let's use our equation. Y equal 1,000, 3, T is 10. So I have 10 divided by 5 because there's the only variable I have in this equation. The T is right there. And I'm solving for the y. So y equal 1,000, 3 squared, y equal 9,000. So the bacteria after 10 days is going to be 9,000. Now that's not the factor. Remember, you started with 1,000. So the factor in this case is 9. We grow by a factor of 9. Again, once you get through once you get through this side of the page, it really isn't that difficult after here. Okay, C. At what time in days will the population have increased by a factor of 6? So again, let's go back to our equation. And now they're telling us we will have increased by a factor of 6, and they want to know how long that's going to take. I'm going to put that up on the screen there. All right, so now I know 6,000 is 1,000, 3 to the T over 5. Easy enough, right? We're in divide, so 6 is 3 to the T over 5. Take the log of both sides. ln 6 is T over 5 ln 3. We're going to divide. Let me just set this up. T over 5 is ln 6 over ln 3. The way that's bled through, it looks like 0.5, but it's not. It's just 5. Okay? So ln 6 divided by ln 3 times 5. So it's going to take 8 0.154 days for the bacteria to increase by a factor of 6. Okay. Then all of a sudden, here we come on D of the question. Using the trapezoidal rule with 3 equal subdivisions, so now everything you've done, you're not doing anymore. So we're going to use the trapezoidal rule with 3 equal subdivisions. So here we go. To estimate the bacteria after 6 days. Again, please, 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 if you're doing trapezoid, do a number line. 1, 2, 3, 4, 5, 6. We're looking for 3 equal subdivisions. So we're going 6 minus 0, b minus a over n. Each one of my trapezoids will have a height of 2. There's 1, there's 2, there's 3. So remember, trapezoid is going to be the summation. Well, remember, it's base 1 plus base 2 divided by 2 times the height. And in this case, our height is consistent with all of these. So I can pull the height of each trapezoid to the front. Also, every trapezoid is going to be divided by 2, so I can pull the 1/2 to the front. And then I'm doing base 1 plus base 2, base 1 plus base 2, base 1 plus base 2. So I'll be evaluating f of 0 plus f of 2. That's my first trapezoid. I'll add to that base 1 plus base 2. There's the second trapezoid. So hang on a second. There's 1, and there's base 1 and base 2. Here's trapezoid number 2. There's base 1 and base 2. I don't know if these colors are picking up, but here's trapezoid number 3. And for that, base 1 and base 2. Okay? So there's base 1 and base 2. Notice Notice the repetition. We've got 2 f of 2s and 2 f of 4s because f of 2 is base 2 to trapezoid 1, but it's base 1 to trapezoid 2. So here we go. We've got the summation. 2 times 1/2, of course, is 1. I've got f of 0. I've got 2 f of 2s and 2 f of 4s, and then 1 f of 6. Okay. So now you have to wonder, what is our equation? Well, again, let's go back to y equal. And our equation now, and this is going to be a little tricky to type in, but here you go. You have 1,000 times 3 alpha y equal, to pull up the fraction, x over 5. Notice where my cursor is. If you've got this software, if I put the parenthesis there, it's going to parenthesis the x over 5. I want to just toggle one more time, and there's my full parenthesis. That's the equation we came up with. Okay. I'm going to go over to the table, and I'm going to evaluate f of 0. Hang on one second. Let me get this. Okay, f of 0 gives me 1,000. F of 2. Remember, we're doing 3 decimals. When I plug in 2, I get 1551.8. So what I'm going to do is scroll up and over, and notice at the bottom of the screen the entire decimal. So I've got 1551.845. Back.
Pause just a second.
Mm-hmm.
Okay, you're back.
Okay. And then f of 4 gives me 2408.224. And then f of 6, 3737, whoops, 0.192. Okay. So let's just go through the numbers real quick. Back to the home screen. Excuse me. So if I use the trapezoidal rule, I'm coming up with total bacteria is 12,657.333. Not uncommon for you to integrate by hand, and then all of a sudden they're going to throw in a right Riemann sum, a left Riemann sum, a trapezoidal rule. So don't let that throw you. It's going to be everything you've done before. Okay, everybody all right? No. Okay, let's go over to the A79 then. Let me organize this. And I'll post these notes, of course, online and send them out to you, because I know it's a lot. Okay, A79. The rate of consumption in cola in the United States is given by dy dx, or excuse me, dy dt is ky, where y is measured in billions of gallons, and t is measured in the years beginning in 1980. That's kind of important. Just keep that in mind. Highlight it if you need to. This is going to be times 0 for our purposes. The consumption rate doubles every 5 years. And the consumption rate at the beginning of 1980 was 6 billion gallons per year. So at times 0, I was at 6 billion gallons. Which means at time 5, I'll be at 12 billion if I'm doubling every 5 years. Excuse me. Okay, find the variable c and the variable k. So again, we're going to do what we've done. We know that this time they actually gave us the differential equation. dy dt is k times y. Separate. Integrate 1 over the stuff. Constant of integration. That should be fairly routine by now. Separate, integrate, constant of integration. Okay, initial condition. They tell us at time 0 we have 6 billion gallons. That's a lot. Hang on, I'm trying to figure out how I want to work this. Bear with me just 1 second. I have this worked out 2 separate ways. I want to see the path I want to take real quick. I thought I had it right here, but apparently I do not. All right, let's go. ln 6 is k times 0 plus c. Excuse me. So I know that c is equal to ln 6. Now, if you want to go through the whole routine, you can. Remember, we're looking for the equation. So we have ln y is k times t plus ln 6. We're going to PERT, e to the kt, e to the ln 6, there's my 6. So y is equal to 6e to the kt. Everybody good? Okay. Now, they also asked us to find the variable k. So we will. We know, and we're going to use the condition that in 5 years, we've doubled the gallons. So now I know 12 is 6e to the 5k. 2 is e to the 5k. I'm going to bring this all the way back up to the top. Yeah. Okay, so 2 is e to the 5k, natural log 2 is 5k ln e, of course that's going to 1. So k is ln 2 divided by 5. Which means, again, base log base, that e is going to turn into a 2. So now I've got y is equal to 6 times e ln 2 over 5 times t. That t is over 1. Base log base, this e is going to change into 2. So I end up with an equation of 6 times 2 to the t over 5. Okay? Everybody with me? Kinda, sorta? So there is the variable c, ln 6, and the variable k is ln 2 over 5. Now, part B. Find the average rate of consumption of cola over the 10-year time period beginning in 1983. So be careful with this piece, because what we're going to be doing, your natural inclination, and also its average. So average is 1 over b minus a times the integration from a to b of your equation. So we're looking at a time period of 10 years. So 1983 would be time 3 for us. So here we go. We're going to be doing 1 over 10 minus 0, and we're going from 3 to 13. It'd probably be better if we did 13 minus 3 right here. I already know it's going to be 10, so I just sort of fudged that up just a little bit. But it's important that we're integrating from 3 to 13. This isn't taking off the first year that the cola is produced. It's taking off in year 3, so the volume is going to be quite a bit higher. And we're integrating 6 times 2t to the 5th dt. Again, this is not an integration you're going to do by hand. So what we're going to do is go to y equal. I'm going to clear all that out. I'm going to clear this out. And my equation is 6 times 2 okay, make sure you get that in right. Okay. Going back to my home screen. Let me just clear out everything I've got there. Math 9. We're integrating from 3 to 13. And we're going to go pick up the equation we just typed in, vars y 1. And of course, it's always with respect to x. So I've got 196.804. I'm going to divide that by the average of 1/10, or multiply it by 1/10 divided by 10. So I end up with 19.680 billions of gallons consumed from time 3 to time 13. So how far off would you have been if you had started from 0 to 10? Well, you can check that out pretty easily. If we integrate from 0 to 10, and then divide that by 10, you would have been at 12.984 billion gallons. So you would have been off quite a bit, 7 billion gallons. Now, of course, we know those mistakes are going to be made, so keep in mind, as we're getting closer to the test, you get credit for setting your integration up right. There would probably be a point for limits of integration, especially in this case where you're not starting at 0, and do you recognize that you're not starting at 0? So there'd probably be a point for that, and a point for the integral itself, and then your answer. So if you lost this point, you would probably get the point for the 12.904, even though your answer's wrong, you did all the work correctly. So show your work. Don't forget about that. All right, then they jump into use the trapezoidal rule with 4 equal subdivisions from 7 to 5 or 5 to 7. So 5, 7, so 7 minus 5 divided by 4. Each base is going to be 1/2. So 5.5, 6, 6.57. So there's 1. There's 2, there's 3, there's my 4 trapezoids. So again, when we're doing the summation, every trapezoid gets divided by 2. In this case, we're lucky all the trapezoids have the same height, and the height is 1/2. So then I will be doing f of 5, base 1, and then f of 5.5. So there's the first trapezoid. And then f of 5.5, f of 6, there's the second trapezoid. F of 6, f of 6.5, there's the third trapezoid. And the fourth, f of 6.5, f of 7. So you've got 2 f of 5s, 2 f of 6, and 2 f of 6.5. All right, take just a minute to calculate that. And I'll be putting the answer up in just a sec. Excuse me. Mm-hmm. Okay. Okay. So these are the evaluations I was getting: f of 5, f of 5.5, f of 6, f of 6.5, f of 7, do the magic that's math, and I end up with 27.668 billion gallons consumed using trapezoidal rule. Okay? All right, I think that's all we have time for. Let me give you the, I know I ran over just a little bit, but let me give you the answers real quick. For D of this question, you're going to get, it's the total cola consumed in billions of gallons for a 2-year period. That question is not uncommon. If you would, tonight work the oil being pumped out, 79.2, and I will see you tomorrow. Thank y'all.